All right, section 1.7. It says they're called radical expressions. So when you say that word radical, back when I was a kid in the 80s, early 80s anyway, I was a kid, I guess. Um, there was an expression going. You ever hear that? Something was like really wild and crazy and cool. People say, "Oh, radical." And nobody says it. Back then, it was actually kind of cool that people would say it. But now you say it, and you're like, "What? You got to be kidding me!" So that's the way. I mean, when kids think they're so cool about saying things now, like John. You ever hear about that John? Yeah, see that John over there? It's like they think they're so cool for saying that. I'm thinking, look, just give it a couple years and it'll sound ridiculous, and people will be so embarrassed. Can't believe I said that, And that's the kind of way radical is now. If you saw something, you're like, "Ooh, wow, radical." So anyway, that's not the kind of radical we're going to talk about. A radical, listen now, a radical is it's not just a square root, but it's any kind of a root. Okay, so it could be a square root, cube root, fourth root, fifth root, and that kind of thing. This little symbol right here is a radical. That little people say, "Oh, it looks like a check sign." Well, it's a radical. That's what that little symbol is called. Okay, it's not just a square root, but it could be a square root. Now we've actually learned a little bit of this before. Let me show you a little definition. If I had I'm going to write it like this. That's an N right there. These could represent numbers, okay? I could stick a number in for A, stick a number in for this. This is a little tiny number off to the side of that little radical symbol, okay? So, for instance, if I had something like this. Oops, I made that a little too big. Let's make it like that. What does that mean right there? That means the what? What is that 3? It's the cube root of 8, right? It's not the square root. It's the cube root. That's why that little 3's there. It's the cubed root of 8. Or you could say it's the third root, but with squares and cubes, we give them special names. After that, we just say the fourth, the fifth, the sixth, okay? But this one, we give it a special name. We say this is the cube root of 8. Well, what in the world does that mean? What does it mean to take the cube root of 8? Well, what number times itself again, right? They have to be the same exact numbers. We'll do like this. Okay, what number times itself again is equal to 8? Well, what is it? 2, right. So the cube root of 8 is equal to 2. Does that make sense? Because if I put a 2 here, a 2 here, and a 2 here, 2 times 2 times 2 is 8. All right, that's the cube root of something. You could also have like this. What if I had the fourth root of 16? What is it saying? It's saying what times itself times itself times itself again 4 times is equal to 16. Well, what number can I put in for x? It has to be the same number, right? 2 times 2 times 2 is 8 times 2 is 16. And so the fourth root of 16 is 2. I just happen to use the same number here, but that's okay. All right? Does that make sense, what we're doing? Well, here's what they're really showing you here, and we've done this before. If I have the nth root of a, that's how we would say that, right? Because this would be the fourth root of 16. This would be the nth root of a. That's the same thing, and we just talked about this not too long ago. It would be the same thing as a to the 1 over n power. All right, like that. That's a very general description of this. But let's take a look at this. Let's do the cube root of 8 again. If I said the cube root of 8, what's another way to write that? I could write it 8 to the what? 1/3. Do you remember that? Right? Because didn't we have this? I think we wrote it down like this. What's x to the 1/2? It's the square root of x, isn't it? What's x to the 1/3? It's the what? It's the cube root of x. You follow me? X to the 1/4 is the same thing as the fourth root of x. It's really saying the same exact thing. It's just kind of going the other way. So it goes both ways. If I have a to the 1 over a power, it means the nth root of that base right there. So for instance, if we may not be able to figure this out, but what if I said this? The fifth root of 37. Now that doesn't come out to a nice pretty number, but I could rewrite it as a fractional exponent. Okay? Right, it'd be 37 to the 1/5. It's exactly the same exact thing. Alright? So those two are the same. Does that make sense? So that's how we want to rewrite stuff. Now, we can't really do this and come out with a nice even number. You could put it in a calculator if you wanted to, but we're not concerned about that. We're gonna work with numbers that I believe come out to nice integer or whole numbers. Okay? Everybody okay with that so far? Alright, let's go to something a little bit different. Well, let's do a couple examples after we get rid of all this mess. Let's do a couple examples right here. Yes.
Are you able to work?
Alright, let's try this again. Let's do just a couple examples. What if I did this? Okay, I rewrote this wrong. Let's do this. Alright, there's a negative out in front. It's kind of floating around. I guess I could put it a little bit closer. Right there. Okay, so what if I had this? Does this mean negative 4 times the square root of 16? Is that what that means? No, this is the 4th root, and it's just a negative out front. See how it's just floating out front right there? So I don't even really have to worry about it that much. All I do is just stick it out front. Okay, I don't really have to apply it to this. It's just you figure out what this is, and then it's just negative, whatever that number is. Okay, that's not that big of a deal when it's out front. What is the 4th root of 16? It's just 2. We already did it, right? So we got a negative out in front, so it actually becomes what? Negative 2. All right. What if I did this? All right, let's look at this one. It's the cube root of negative 1,000. The cube root of 1,000. Let's think about it. What times what times what? Or I shouldn't say that. What times itself is equal to negative 1,000. What do you think? Yeah, it's 10, but not just 10, because 10 times 10 times 10 would be 1,000. But watch, negative 10 times negative 10 would be positive 100, times another negative would be negative 1,000. So that's the cube root of negative 1,000. Does that make sense? Right? And these are numbers that you should be able to deal with, and you should be able to do this without using a calculator. The cube root of 1,000, right? You should be able to think, okay, 10, 10, 10, that's 3 zeros, right? And so that's 1,000. So you should be able to work with this and with this without a calculator. Now these numbers may not be quite so easy. Watch. I'm going to really mess with you here. Alright, and put 6 out here. So this is the 6th root of these. Now, I would say this would be a calculator problem, but if you can still do this, I bet you could do this without a calculator. Because watch. What about 64? You already know up here that like 2 to the 4th is 16, right? You see that? 2 to the 4th is 16, so what does that mean? The 4th root of 16 is 2, right? 2 to the 5th. What would be 2 to the 5th? It's just this times 2. What's that times 2? 32. What's 2 to the 6th? That'd be 64, wouldn't it? What's the 6th root of 64? It's 2. You see that? It's just a 2. What about this? The 6th root of 729. Well, let's just try another number. Let's try the next one up. Let's try 3. I'm just showing you that you could do this without a calculator. I mean, it'd be a little bit extra work, okay, but it wouldn't be that hard. Yes. Yeah, try a number. Try the next one up. Because you know it's going to be bigger than 2, right? Because the 6th root of 64 is 2. So let's try a bigger number. Let's try 3. What's the biggest one you know off the top of your head? Probably 3 cubed. What's 3 cubed? 27. All right, 3 to the 4th. Now watch, here's how I do 3 to the 4th. 3 to the 4th is 3 squared times 3 squared, right? So that's 9 times 9, and that's 81, right? Or you could just say 27 times 3. 3 to the 5th, I tell you what would 3 to the 6th be? It would just be this times another what? 9. So let's just do that. Watch, that's a 9, that's a what? Wow, look at that. So what's the 6th root of 729? It's 3. There it is. So you could legitimately figure that out, couldn't you? All right, I just went to the next number. What if that didn't work? Go to the next one. Try 4 and see if it works. With this right here, there's a button on your calculator. Depends what calculator you're using. If you just have one of those little scientific calculators, which I would suggest because I think they're a little easier to use, to tell you the truth, on stuff like this, it's only like 10 bucks. Most of you, well, half of you have them. So you'll see this button, right? Doesn't it say y to the x? Yeah. And then you'll see one, let me see what it says. Yeah. you'll see 1. And then if you do the second function, which is the little yellow one above it, it'll look like this. Okay? You guys probably have to go to menu or something. I forget off the top of my head. I'll have to look. I'll help you. I'll help you in a few minutes. But anyway, on a little calculator, on a little TI-30, you'll have a button that looks like this. Okay? And so that's like, so let's just do 64. So what you would do, you hit 64, right? Then you'd hit this button, and then you'd hit what root? You'd hit 6, hit equals, and you'll see a 2. Then you try 729, put it in here, right? Hit the 6, right? Hit this button, then hit 6, and you'll get a 3 out of it. Does that work? You could do it all together if you want. Yeah, you could do it. I mean, you could do it all together. Let me try to find where my buttons are. There they are. 64, hit that button and hit the 6 root, and then, yep, 2. It works nice and perfect. Okay. Problem is, if you did this, if you stuck that in your calculator, you'd get a decimal, and you could still hit the 6 root. You'd still get 2/3, but it would come out as a decimal. Then on your calculator, you can actually take a decimal and change it back into a fraction if you wanted to. But to tell you the truth, I think it would be just as easy just to take the 6 root of 64, find out the 6 root of 729, put one on top of the other, and then you'll be done. Okay? We good with that? All right, let's try a little bit more. Okay, this next little part just says write it in radical form. So watch what they do. They go, and we've done this before. All right, this is something we learned. I'm not sure why they put it in this chapter because we've actually talked about this. Well, I think the thing was about fractional exponents, and we kind of figured out how to do this. But remember this one? You had it on the quiz, didn't you? Something like it, right? Very similar to it. So how do we rewrite this? I'm going to write it as 8 to the what? To the 1/3 first. Okay? And then I'm going to take it and square it. So I broke it down. Now if you wanted to, you could have done this. Here's an option. This is optional. You could have gone 8 squared and taken to the 1/3 power. You would. But if these numbers get bigger, it doesn't take much for this to be a lot more complicated than this. Because what would this be? 8 squared is 64. And then what does that mean to the 1/3 power? That means the cube root of 64. Okay, and we've done that. But what's the cube root of 64? What times itself times itself? 4. 4 times 4 is 16. 16 times 4 is 64. But that was a little bit more difficult. The number was still pretty relatively small right here. When those numbers get really big, then it's going to be really, really hard. Almost impossible to do that in your head. On this one, it's easy to do in your head. They rig these a little bit so that you can do them in your head. All right. So watch. 8 to the 1/3. What does that mean? That means the cube root of 8, doesn't it? So what's the cube root of 8? It's 2. Right? That should just be like quick common knowledge at this point, right? 2 cubed is 8. You don't even have to think about it, do you? Right? You've done those so much. So the cube root of 8 is 2, and then what are we doing to it? We're squaring it. What's 2 squared? It's 4. Don't you think this was a lot easier? Yeah, there's a lot easier work in your head than this was. This wasn't super hard, but I'm telling you, when these numbers get big, it's going to be pretty crazy. I'll show you one. Let's do this one. -32. Now this time it's in parentheses, and it's to the 4/5. Now if you wanted to, you could go -32 to the 4th power. Is there any way in the world you could do that in your head? 32 to the 4th? 32 times 32? I can't even do 32 squared in my head, all right? So there's no way I'm going to be able to take it to the 4th. You all right with that? Would you agree that that option's not a great option? All right, so let's do it the way we would normally do it. So I would go -32, keep the negative because it's in parentheses, take it to the what? To the 1/5. Figure out what that is, and then take that number to what? The 4th. Okay? So let's figure it out. To the 1/5, what does that mean? That means the 5th root of 32. So what number times itself 5 times is going to give you 32? It's going to be -2, isn't it? Right? We already talked about that number just a little bit ago. All right, so 2 to the 5th. Again, that should be a number that you just look at now since we've done it a few times. 2 to the 5th is the same as 32. But we put a negative because negative times negative times negative 5 times is -32. We take that to the 4th. What's that? That's positive 16. Right, it's positive, because when we take a negative to an even power, then it's positive 16. Oh, you guys didn't tell me I went over 15 minutes. Actually, I did that on purpose. I saw it happening because I got a little note yesterday that said that now I'm eligible to go more than 15 minutes, but I don't know how much longer I can go. It never said how long you could go, so I'm gonna see. I'm gonna find out. Right. Okay. Let's do another one. Okay. Watch. This whole thing says write in radical form. Well, all these you could always simplify, because what did I do? I actually took a radical, didn't I? I took the cube root, but it simplified to be a nice whole number. Look, I took the fifth root, but it came out to be a nice whole number. They're not always going to come out to be nice, pretty numbers. If it says put it in radical form, what I want to do is I want to write it as a root. So technically, like this one right here, let's do this one. I could have written it like this, 8 to the 1/3. Instead of 8 to the 1/3, I could have written it the cube root of 8, couldn't I? And then taken that thing and what? Squared it. That would be in radical form right there. But this thing simplifies. It simplifies to be 4. You'll always simplify it. Okay, if it can simplify to a nice whole number. It doesn't always simplify to a nice pretty whole number. For instance, what about this? X to the 5/6. We want to write this in radical form. You're not really solving for it. You're not really even simplifying it. Okay, all you're doing is just changing it from exponential form, right, because that's an exponent, to radical form. We want to write it with a root in there. So how would I write this? First I'm going to write it like this. Let's write it and split it up, okay, like we did these other ones. So let's write it x to the what? To the 1/6, right, to the denominator. And then take it to the what? 5th. Now we can take this and write that as a radical, can't we? So what's x to the 1/6? It's the 6th root of x. Okay, what do we do with that whole thing? We take it to the 5th. That right there would be in radical form. Now, is that a better form than this? Not necessarily. Okay, but that's what they ask you to do. They just want to make sure that you know how to change it from an exponent to a radical. Now, if you could simplify this, then you would go ahead and figure out what that is and take it to the 5th and go on from there. But you can't, because that's an x anyway, right? So they're exactly the same thing, except one's in exponential form and one's in radical form. We good with that? Okay. Let's do one more. Let's do it right here. Let's go 2p to the negative 1/2. Talked about this yesterday when we went over the quiz, didn't we? What do we do with that right there? Flip it to the bottom, right? So it's over 1, and so what's going to be on top? The 2, right? Because we don't move that 2. We just take this, flip it to the bottom, so that would be p to the what? 1/2. But the question says write it in radical form. Not every question asks you to do that, but on this one it does. So 2's on the top. How am I going to rewrite that as a radical? That's it. Just put square root of p. And we'll leave it like that. Now technically, we're going to learn something a little bit later. It could be in this lesson too. I'm not really sure. I'll have to look ahead. Let me see. Yeah, it's later in this lesson. We're not going to leave the denominator with a root. All right, we'll talk about that when we get to it. All right, but that would be in radical form, wouldn't it? That's what they give you, and this is how you would want to rewrite your answer in radical form. All right. All right, we got a few more minutes. Let's do a few rules. Okay, these are some basic rules for radicals. Rules for radicals. In real life, it seems like if you're a radical, you wouldn't live by any rules, would you? So it's kind of an oxymoron, isn't it? So, but anyway, we're doing math radicals. So of course we have rules. I think that's why I like math, because I'm a rule person. I really am. I think I discovered that. You don't think about that, like what kind of person you are like that, but I feel comfortable with rules. Some people hate rules and they want to do everything they can to go against the rules. I'm opposite. And there's good people, real good, moral people that they just don't want people telling them what to do. And I'm very comfortable with people telling me what to do, to tell you the truth. All right, here we go. Here's one rule for radicals. Multiplication rule. Okay, these are being multiplied together. Now watch. They're individual radicals. Okay, it's a very easy rule. You just put one radical and you just multiply the stuff in here. So it's just what? A, B. That's it. All right. So if I had this, if I had the square root of 3 times the square root of 2, how could I multiply that together? I just get one big square root and I multiply those together. So 3 times 2 is 6. That's all there is to that. It's a nice easy rule, isn't it? Yeah. Okay, it works the other way too. What if I had this? What if I had the square root? Let me think of a good one. Let's say 32. What if I had the square root of 32? Watch what I could do. We'll get into this a little bit more later, not so much right now, but let me just show you. You probably saw this in Algebra 2, maybe even in Algebra 1, I'm not sure. If I had the square root of 32, you could write it 16 times 2. Would you agree that 16 times 2 is 32? Watch what the rule says. Watch, I'm going to take this rule and go this way. So I could write it like this, the square root of 16, and then break that up into the square root of 2. See how I just kind of went backwards on the rule? Square root of 16 is 4, and then you just keep that the square root of 2, and now that's what that is simplified. Okay, do you remember doing that in Algebra 2? Yeah. So we'll get into that a little bit later, but that's where that rule comes from, and that's why you can do that stuff right there. All right? Let's do one with division. We kind of already did one, but watch, put A over B. Now, looking at this rule, actually I should have done it the other way. It doesn't matter which way you do it. What do you think? This is A times B. What'd you do? You broke them both up into their individual square roots, didn't you? So what do you think you're going to do here? I break them up again, but now it's division, though, instead of multiplication, isn't it? So what's it going to be? It's going to be the square root of A over square root of B. See that? So if I had a fraction, so for instance, if I had the square root of 9/4. Now, will 4 go into 9? No, so you can't simplify that, but we kind of did this before. Remember that 6th root of whatever those numbers were, 64 and 729? Watch, what would we do? We'd write the square root of 9 over the square root of 2. They rig these things so it comes out nice and even. So the square root, thinking ahead. I'm thinking of what the square root of 4 is. Right, that's what I said. I was thinking ahead, and I was thinking that, that was going to be a 2, so I put a 2 here. So what's the square root of 9? It's 3. And what's the square root of 4? It's 2, and then there it is. Okay, why can we do that? Because of this rule right here. Okay, division rule. Watch this one. This one's crazy. This will be the last one we do. Big thing out here, thing in here. Watch. It's the root of a root. You see that? Alright, watch. This is kind of interesting, though. Watch. It's a root right here inside of a root. What we can do, if you want to, we can kind of show you why it works. Let's do this. Let's change this to exponential form just to show you why this rule is going to work. And you don't even see what this is going to equal yet. I want to get to it, okay? Let's kind of come up with it on our own. So let's just take a look at this. The nth root of a. How could we write that? A to the what? To the 1 over n. And that's taken, right? That's inside another root, so what are we going to do with that? Take that thing to the what? 1 over m power, right? So what's this going to be? This is going to be a to the 1 over n times m. You see that? So here's another way we could write it as a radical. You could write it, that's your base, and what's your thing out here? It's nm, that's right. And that's the rule. Or you could write mn. It doesn't really make any difference what the order is, does it? If you feel a little bit better, I'll put mn. You see that? So this is the rule. This thing right here, if you have a root inside another root, what can you do? You can just multiply the two roots together and take a to that root. Isn't that weird? Let's do an example with that. Put a 2. So cube root of 2, and then inside that, we're going to take that to the 7th root. So what's another way to write this? Now, it's not going to come out to a nice even number, but we can rewrite it, though. What do? It's a root inside a root, so what do we do with those two roots? Multiply them together, right? So keep the 2 there, right? Because we kept the a underneath of the root, didn't we? So what do you do with those two? multiply them together, and what do you get? So it's the 21st root of 2. That's how you would rewrite that. Now sometimes they'll rig it so that you can figure that out, but all we're doing is just changing it and simplifying this form into this. Isn't that crazy? We good? Alright, well, there is a little bit more we can do, but we're running out of time, so we'll stop right there. And we'll see if YouTube takes my video at 25 minutes plus.